Now we're starting our new section called matrices. It's all about systems of linear equations. So let's start off with how would you solve this system of linear equations? These are linear because they're just made up of two variables, x and y. So how would you solve those? You've actually got three options, so let's go through all three just so you're aware. So you could use substitution. If I was going to use substitution, I would rearrange one of them to make it a little bit easier. So because it's minus y, what I'm going to do is take that over so it's plus y, and then take the 7 off. So if I rearrange the first equation to y equals 5x minus 7, then what I could do is then use it and substitute it into x plus 2y equals 8. So where y is, I'm going to replace it with the 5x take 7. So that'll be x plus 2 lots of 5x take 7 because it's 2 lots of y. Now let's expand that out. That'll be 10x take 14 in there, and that gives me 11x take 14. If you take the 14 over, it will turn to 22, and you get out x is 2. Now I've done a lot of work, but I've not found y yet, so let's go and find y now. So let's substitute x is 2 into this, and y equals 5 times 2, which is 10 take 7, which is 3. So you've got your solution, that is x is 2 and y is 3. You've done substitution before. Some people prefer it to elimination, some people don't see this, okay? It doesn't matter which technique, we're looking at all the different ones you can have. Elimination's more popular, just make sure you have the same variable in the same place. So what I mean by that is if I start with 5x take y equals 7, make sure you've got the x under the x and the y under the y. What could you do there? You could just double the top row and have 10x take 2y equals 14. Remember, you have to double the whole row. And then if they're the same sign, subtract. But if they are different signs, so what we're going to do is eliminate the y's. If we collect both together, so you'll notice it depends on your teacher and whatever textbook you're using. I sometimes don't bother renaming it, but what I have is two equations, and then when I jig it around, multiply it, I've called it equation 3 so that you know what I'm talking about. Some people don't do that, but that means what I'm going to do next is tell you I'm going to add the 3 and the 2 together so that you get 11x, they cancel, equals 22, okay? And then you'll get x equals 2. Same again, find y. So again, substitute in, so 5 2s are 10, aren't they? And you get your y is 3. I'm more of an elimination fan, but it's entirely your call. It's just showing you get the exact same answer. And then graphically is the hardest work because you've got to produce a picture. So if I was going to try graphically, I'd put x equals 0 and y equals 0. So let's start with the first one. If you put x equals 0 in there, you'll get 5 zeros. So you end up with minus y equals 7. So plus y equals minus 7. And you've got a point 0 minus 7. If we put in y as 0, you'll have 5x minus 0 equals 7, so 5x equals 7. Not a nice answer, but that's the way it is. So x equals 7 divided by 5. Whether you're right, it's 1 2/5 or 1.4, I'm not worried. So then what would you do? You would plot 0 minus 7. So if I were to plot 0 minus 7 and 1.4, make sure you've got them the right way around. The x is 0, you went none along and 7 down. So 1, 2, 3, 4, 5, 6, 7. And then this one is no height. So this is 1.4 along. And so just before the halfway mark. And then connect them up. So there's your first one. I've not labelled it there, but you know what we're doing here. Okay, and then do the same. So in the next one, put x is 0 in, and you'll get 2y equals 8, which is quite nice. So y is 4. So you know it cuts at 0, 4, none along and 4 up. And then lastly, if you put y as 0 in, you'll end up with simply x is 8 because this will disappear. So there was another way. We'll just count 1, 2, 3, 4, 5, 6, 7, 8. And then what do? Connect them up. And then you can solve a system of equations graphically by seeing where they cross. Now we can see they cross the point of intersections here. So that's 2 along and 3 up. So we can write it as 2, 3. And we could say x is 2 and y is 3. So what I'm showing you is you have solved systems of equations before. You've used substitution, you've used elimination, and you've also used graphical methods. Probably more consistent to us is using elimination, but we don't always just have x's and y's, and this is where we're leading to in this chapter. Okay, two equations, 5x take y equals 7, and the x plus 2y equals 8 have unique values for x and y that satisfy both of the equations. The equations can be solved either by algebraic or by drawing the graphs of each one to find the point of intersection. And this can be achieved because the equations of the lines are in a plane. So when you plot x and y, it's actually like a flat sheet of paper, okay? We obviously know 3D vectors and so forth, and we use x, y, and z. So here the blue sheet of paper would be your x and y, and we have a nice set of points because they're both linear and they both touch at one point, okay? So when we talk about things in this section and in other sections like vectors, remember a plane is like a flat sheet, if that helps, okay? So what happens, however, if you've got a system of equations that's got 3 unknowns, 4, or even more? That's what this whole section's about. So with systems of equations and 3, 4, or more unknowns, it's very complicated algebraically, and using simultaneous equations doesn't work. Graphically, I'm not going to even go there to try to draw. So this unit will begin to explore the ideas of something called matrices, which makes it much easier for you, and how they can be used in various situations to provide information in several related linear equations. That is, information in systems of linear equations is what this topic's about. Before we start the topic, just as a little recap then, can you please try these 3 quick questions just to make sure you've got the idea about what you do with simultaneous equations. Of course, you can use substitution or graphical method, but I would recommend you just go straight for elimination. Okay, these are from page 198 in the Scholar Unit 1 textbook, but you can just take them from here. They'll be on the PDF, but to check your answers, go to the Scholar Unit 1 and 295 where your answers are, and then we'll start the actual topic. Okay,